Good morning. Welcome to Physics in the AM. I'm Sundar. Just so you know, today we went over the momentum assignment for the small one-page quiz, two sides of the paper. And we finished up our activity on kinetic energy and potential energy, and that leads us right into conservation of mechanical energy. And it's simple. It's just, this is why the momentum thing is conservation of momentum and conservation of energy is in the same unit. They're different concepts, but they're conservation ideas. The total energy before is equal to the total energy after. We're sticking just to kinetic energy before, kinetic energy, potential energy before P1, or K1 P1 equals K2 P2, right? And anywhere in between too. Now, I said energy concepts are a lot easier because it allows us to analyze things without breaking things down into their vectors. Energy is not a vector quantity, so we don't have to use sines and cosines. So it's a lot easier in some ways. Find the total mechanical energy of a 48 gram golf ball. We need that in kilograms. If it has a speed, I'm going to change that. If it has a speed of 25 meters per second as it leaves the club. Okay? So, oh, good gravy, where did I put that? Right here. So I understand the situation. Maybe not. That's the potential path, right? We've done problems like this, not energy, but height, velocity, and stuff like that. We figured this out, but we have to use sines and cosines to break it down to vectors. The total mechanical energy. First of all, I mentioned we can just do this in our head. We have to divide a smaller number into it. So 0.4 divide by that. No. Total energy. And I'm not saying before or after, we can choose the scenario we want. Is equal to the kinetic energy plus the potential energy. Where do we have enough data to come up with potential information? I'll ask you if it's at this starting point, 1, or at this point, 2, or at 3. Yes, yes, or total energy. I think 2, though, let's just think about this. Okay, let's just make an assumption. We have to define where our 0. Where's the most logical place to place 0 height? At 1 ground level. This is just when you're hitting the golf ball. What is the potential energy then if the height is 0? Yeah. That means you only have kinetic energy to figure out at position 1. It's the best spot to do. Let's just think about, we're not going to do 2, but in position 2, you have height. I don't know what it is. So you have potential energy and you have velocity. Okay, so let's go back. We're going to use position 1. Oh, that's disappearing. I'm going to say at 1. Energy total equal to kinetic energy plus potential energy. But I'm going to just say that's zero because I know MGH times zero height. That makes this easy. This is equal to the energy total is equal to kinetic energy. It's 1/2 mv squared. Okay. And we just plug in the numbers now. 1/2 0.048. Velocity 25 meters per second. Square. I think we all know how to use a calculator. I'm going to round it off, and I've done it. Remember that 25 is square. And I have it as 15. Now, the next question is related to position 2 that Luke was mentioning. So let's just think about this. I'm not worried about the angles, remember? So this makes it a lot easier. Position 2, just intuitively, will the ball have sped up or same speed or slowed down? Slowed down. So that means the amount that this is slowed down, that's reduced kinetic energy, that's picked up by potential energy. Right? And ignoring air resistance, it's actually going to land with the same kinetic energy to start. So to do question B, the ball travels an arc, I have that drawn, has a speed of 15 meters per second at the maximum. What is the maximum height? This is the second. At what we labeled as 2. B is equal to 15. Just like the same now. The energy total, we have over 2. Kinetic energy 2. Here's the interesting thing, though. Energy is conserved. We're not worried about wind. So energy, total energy in the second position is still 15. It's not bad. Kinetic energy. So total energy we have. Kinetic energy we have to calculate. 1/2 mv squared, so 0.48. Kilograms times the new velocity, 15 meters per second squared, plus we want the maximum height, mgh. So I'm going to use the mass, 0.08, 9.8, 0 meters per second squared. I'm going to cram this in here, h. H is what I'm solving. I'm going to let you guys do the algebra. I'll pause this and come back to it. So we can get solved. Okay. I will show the algebra, but what is the answer height-wise? 2.05. Any other answers? 20. We better go through this. What? 2.6, 20. Who's putting money on who? Yeah?
I also got
Okay, I'm putting my money on Kirby then.
not bad on myself.
Okay. Okay. Oh, I froze this, so just a second. Right? Okay, there we are. Algebra. You guys come up with a kinetic energy value. 5.4? Okay, yeah, I got 5.4 as well. Then these two, the 48, 0.48, and 980 multiplied, you get 0.47. Right? I'm going to keep the 0.4 behind me. 0.47. These aren't significant. Kilogram. That's times h. You know, algebra-wise, you have to subtract the 5.4 from the 15, and we get 9.6. I'm just keeping that 0.4, knowing that it's not significant. So I wrote it small. And I won't. Now we have to divide, right? And we do get 20. What's the unit? You can just trust this because you know it's a height. But if we want to break down what a joule is, kilogram meter squared per second squared, and then divided by kilogram meter per second squared, there are only round. Okay? Now I'm keeping two digits in significant value. 2.0 times 10. Anyways. Is that better?
I screwed up. When I multiplied math, I put gravity, I put the 0.4 instead of 0.8.
Right. Now, you knew the physics though. Yeah. That's the important part. Yeah, well, the algebra is important, but I mean, I'm not here to teach algebra as much as I am here to teach physics. Now, we are going to take a look at some questions, but before we do, I have to change. I don't know about this video compared to what I showed last year, which is no longer available. Let's just take a look at this. And I'll even try to record it. Oh, I'll turn on the volume. When a ball is first, oh, okay, I'm going to, there's no sound on this. Do I? Oh gosh, no wonder why. Okay. Try it again. There's just nothing interesting to say about this though, because I do have the volume on. Okay. Did you read that? While the ball is falling, I'm going to go back here because I was expecting some sound here. I'll narrate. At the top, you know, just potential energy, right? The ball is first dropped, it's using gravitational potential energy. That's being translated every second into some kinetic energy. When it hits the bottom, it's at maximum kinetic energy, and we will assume 0. Then there's elastic energy. We don't talk about that. That bounces it back up, though, right? The kinetic energy is all transformed back into potential when it reaches the same height. The total energy is the same at all times. And then, of course, yes, because you lose, it keeps bouncing and stuff until it loses. This isn't as good as the video that I had before, but it's similar. It makes sense, though? Okay. I could tell you guys and long for the old video that I had, but oh well. It's not that big. No better way to learn to do but by doing. You guys are going to try these questions from the textbook, but I have them right on the sheet, so no need to dig it up. 15 through 18. And it's awesome because we don't have to use sines and cosines.